Today we are going to look at complementary angles. Let us recall the trigonometric ratios of specific angles that we saw in the last lesson. Recall that sin 30 was equal to cos 60 and cos 30 was equal to sin 60. It is interesting to note that 30 degrees and 60 degrees add up to 90 degrees. Let us look at the sine and cos values for 0 degrees and 90 degrees. Sin 0 equals cos 90 and cos 0 equals sin 90. Once again, it is very interesting that 0 degrees and 90 degrees add up to 90 degrees. Any two angles that add up to 90 degrees are known as complementary angles. Let us look at a right triangle ABC right angled at B. If angle C was theta, then I would call the side opposite theta, that is side AB, as perpendicular. The side adjacent to theta, that is side BC, as base. And the hypotenuse AC as H. Now we know that the sum of angles of a triangle is 180 degrees. So angle A plus angle B plus angle C would be equal to 180 degrees. Let us substitute the values for angle B and angle C. So we get angle A plus 90 plus theta equals 180. Or angle A equals 90 minus theta. So the acute angles of a right triangle are always complementary. Here angle A and theta add up to 90 degrees. Alright, now let us look at the trigonometric ratios for angle theta. Let us write down the ratios in terms of P, B and H and substitute the values for the sides. So we get sin theta as AB by AC, cos theta as BC by AC and so on. Now let us look at our angle A or 90 degrees minus theta and define a perpendicular and base accordingly. So this time my side BC would be the perpendicular and the side AB would be the base. Once again, let us write down the trigonometric ratios for the angle 90 degrees minus theta in terms of P, B and H. Let us substitute the values for these sides. So we get the trigonometric ratios for the angle 90 degrees minus theta in terms of AB, BC and AC. Now let us look at the ratios that are in common to these two angles. So we see that sin theta has the value AB by AC and cos 90 minus theta also has the value AB by AC. Similarly, we can see that cos theta is equal to sin 90 minus theta. The values for tan and cot of theta and 90 minus theta are also interchanged. So tan theta equals cot 90 minus theta and cot theta equals tan 90 minus theta. A similar phenomenon happens for the cosecant and secant values of theta and 90 minus theta. So we can see that cosecant theta is equal to secant of 90 minus theta and sec theta equals cosecant 90 minus theta. Now let us look at our trigonometric table for specific angles. Let us look at the columns for 30 degrees and 60 degrees. 30 and 60 add up to 90 degrees, so it is a pair of complementary angles. We can see that sin 30 equals cos 60. Cos 30 equals sin 60. Tan 30 equals cot 60. Cosec 30 equals sec 60. Sec 30 equals cosec 60. And cot 30 equals tan 60. There are two ways to remember these equalities. So the first pair that gets interchanged is sin and cos. Since cosec and sec are the reciprocals of sin and cos, the values for cosec and sec are also interchanged. Now the only pair left is tan and cot. So the values for tan and cot would be interchanged for a pair of complementary angles. The other way to remember this is to look at these ratios in a tabular form. So we see that sine and cos values get interchanged. And the rest of the trigonometric ratios, they follow an arrow in an anti-clockwise direction. Let us look at a few problems. Evaluate tan 65 by cot 25. Now we don't know the values for tan 65 and cot 25. So the very next thing to do would be to see the sum of 65 and 25. Yes, that comes out as 90 degrees. So 65 and 25 form a pair of complementary angles. Now let us look at the values of these trigonometric ratios. We see that tan theta equals cot 90 minus theta. Substituting theta equals 65, we get tan 65 equals cot 25. Dividing both sides by cot 25, we get tan 65 by cot 25 equals 1. You could also substitute the value for tan 65 as cot 25 and still get the value of the expression as 1. Let us look at another problem. Show that cos 38 times cos 52 minus sin 38 times sin 52 equals 0. Once again, we do not know the values of the trigonometric ratios for the angles 38 degrees and 52 degrees. So let us look at the next best thing to do. Add up 38 degrees and 52 degrees. The sum comes out as 90 degrees, so they form a pair of complementary angles. Once again, let us look at the interchange in trigonometric ratios for complementary angles. So we see that sin 38 would be equal to cos of 90 minus 38, which would be equal to cos 52. Similarly, sin 52 would be equal to cos of 90 minus 52 or cos of 38 degrees. So we can see that sin 38 degrees equals cos 52 degrees and sin 52 degrees equals cos 38 degrees. Substituting these values on the left hand side of this equality, we get the expression as equal to 0, which is what we were supposed to show. Let us look at another problem. If secant 4a equals cosecant a minus 20 degrees, where 4a is an acute angle, find the value of a. Alright, the only relationship we know between secant and cosecant in an equality would be with respect to a pair of complementary angles. We know that secant theta equals cosecant 90 minus theta. The corollary was also true. You could write that cosecant theta equals secant 90 minus theta. Both relationships would fetch you the same result. Let us continue with secant theta equals cosecant 90 minus theta. Now we are given secant 4a equals cosecant a minus 20. We can infer from these two equalities that theta equals 4a and 90 minus theta equals a minus 20. Let us substitute the value for theta in the second equation